right, let's wrap up our advanced algebra. We'll analyze some more complex equations in context. So here we have an object of mass m moving at speed v. The object's kinetic energy, Ke, is given by the equation Ke is equal to 1/2 m times v squared. If the mass of the object is halved and its speed is doubled, how does the kinetic energy change? Well, let's see how the equation changed if we actually apply that. So we have kinetic energy is equal to 1/2 times the mass times the velocity squared. The mass is cut in half, so it's being multiplied by 1/2. The velocity is being doubled, so it's being multiplied by 2. We'll simplify this equation. We can go ahead and do 1/2 times 1/2 to get 1/4 times the mass, and when we square 2 times the velocity, we get 4 times the velocity squared. If we take our two coefficients and multiply those together, we end up with mass times velocity squared. Those cancel out. And when we compare it to our original equation of 1/2 mass times velocity squared, we see that when we did those changes, our kinetic energy was doubled. Here was doubled. For a certain reservoir, the function f gives the water level f of n to the nearest whole percent of capacity on the nth day of 2016. Which of the following is the best interpretation of f37 equals 70? Well, we need to figure out what these numbers represent. So when we have this number here, that represents n. If we have f of n, n is 37. N represents the nth day. So the 37th day of 2016. And then our function gives water level f of n to the nearest whole percent of capacity. So f of n equals 70. So 70 represents that percent of capacity. So here, option A, the water level of the reservoir was 37%. No, we don't know that. Our water level was 70%. The water level of the reservoir was 70%. That looks good for 37 days. It's not 37 days. It's the 37th day. The 37th day. On the 37th day, okay, that looks good. The water level of the reservoir was at 70%. That's the one that matches up. A gas in a container will escape through the holes of microscopic size as long as the holes are larger than the gas molecules. This process is called diffusion. If the gas of molar mass m sub 1 effuses at a rate of r sub 1 and a gas of molar mass m sub 2 effuses at a rate of r sub 2, then the following relationship holds. This is known as Graham's law. Which of the following correctly expresses m sub 2 in terms of m sub 1, r sub 1, and r sub 2? Now, all of this is just a setup explaining what this equation does. We don't need to know what this equation does. We just need to know what to do with it. Which of the following correctly expresses M2 in terms of the other variables? To express something in terms of everything else means to isolate that variable. We want to isolate M sub 2. So we take our original equation, r sub 1 over r sub 2 equals the square root of m sub 2 over m sub 1. Well, we need to get that m sub 2 out of the radical. So we're going to go ahead and square both sides to get rid of that radical, leaving us with r sub 2, or r squared, r sub 1 squared, r sub 2 squared equals m squared, m sub 2 over m sub 1, okay? So far, there's only one option that actually looks like this in any way. This is the only one that has r squared sub 1 over r squared sub 2, but let's go ahead and double check to make sure that that works out for us. And so we'll finish by isolating. Well, in order to get the m sub 1 out of there, change to green, we're going to multiply both sides by m sub 1. So those cancel, leaving us with m sub 1 times r sub 1 squared over r sub 2 squared. And we're left with all that equaling m sub 2. So that does indeed match our answer. The absolute pressure P in a fluid of density P is given at depth h and can be found with the equation above, where P is atmospheric pressure and G is gravitational acceleration. Which of the following is the correct expression for the depth in terms of the absolute pressure, atmospheric pressure, fluid density, gravitational acceleration? This is the same as the last question, but down here they're not listing variables, they're listing the terms. So we have to look back and see what those variables are. So which of the following is the correct expression for the depth in terms of everything else? Well, we need to figure out what depth is. Depth is represented by the variable h. So we need to isolate h. So we look at our original equation. First thing we're going to do is get rid of this big P with the subscript. And so we end up with P minus P with the subscript equals PGH. And then in order to get P and G away from H, since they're being multiplied, we're going to divide by P and G. And that leaves us with answer option A, P minus P with the subscript over P times G. All right, we have another one where we're rewriting it just a little bit different. So we have our initial investment. This first part just tells us what everything represents. Which of the following equations shows the interest rate in terms of everything else? So the interest rate is what we want to isolate. And interest rate is represented by R. So we want to get R by itself. So we can get rid of this P to start. Divide both sides by P. Get rid of that. So we have A over P equals 1 plus R to the Tth power. Now when we have an exponent, how we undo exponents is we take the root. Well, in order to get rid of a Tth root or a Tth exponent, we have to take a Tth root. Okay? So when we take the Tth root, that cancels out, leaving us with the Tth root of A over P equals 1 plus R. We end by subtracting 1, but that 1 will not be inside the radical. So we'll have minus 1 on the outside. That's going to equal our R. We look at our answer options and we see none of them have radicals, but we can remember that radicals can be written with fractional exponents. A over P is what's in our radical. So A over the Tth root of A over P will be equivalent to A over P to the 1 over Tth power. And then the negative 1 is right here, leaving us with answer D. Last but not least, we have a store manager estimates that if a video game is sold at a price of $P, the store will have weekly revenue given by this equation. It's important to note that this equation is in standard form. Standard form is really great for telling us y-intercept. It's also possible that we can factor from there. Let's see if the y-intercept is what we need or if we need something else. For the sale of a video game, which of the following equation, or which of the following equivalent forms, so equivalent forms of R of P, shows as constants or coefficients the maximum possible weekly revenue? Well, maximum always refers to the vertex. Okay, well, standard form doesn't give us vertex. Vertex form tells us vertex. So there's a couple things we can do. Recall that vertex form, the general formula for a function, is ax minus h squared plus k. There's actually a little bit more of a variation to this, but this is how most of our standard vertex forms look when we're taking a quadratic and finding it in vertex form. So we could use a process called completing the square. Completing the square will take an equation from standard form and rewrite it in vertex form. But we don't need to go that hard because completing the square is a not fast process. So we don't really necessarily need to do that here. A little bit of a shortcut is that we just need to find the vertex. When we look at these equations, there's not a lot of similarity between them, This is still in standard form, just with the variable switch, so we can ignore that. This just has a common factor taken out, not necessarily even the greatest common factor, so we can ignore that. This has the greatest common factor taken out, but it's still not in vertex form, so the chances are that this is our answer, okay? Because it most closely matches vertex form of the equation, okay? Now, we got lucky here. Let's say we didn't get lucky and we needed to actually figure out what vertex form was, and say they had some other equations that were really similar. For example, maybe they had negative 4p minus 2500 squared plus 25. Say that was another option that we had. Say that was answer option. Not that you'll ever have an answer option E. Well, how do you know which one to pick, which one's going to work? Well, we need to figure out what the vertex actually is. So instead of completing the square, we can use our vertex formula. Recall that that is x will equal negative b over 2a. Again, this finds the x value of our vertex, so we need to figure out what that is. Again, looking back up at our standard form, b is 200, a is negative 4. When we solve that, we get 25. So the x value of our vertex is 25. The y value would be what we would get if we plug 25 back in to our equation. R of 25 equals negative 4 times 25 squared plus 200 times 25. We evaluate that, and that does give us 2500, which is the y value of the vertex. Recall from vertex form, h and k are the x and y values, respectively, of our vertex. So when we look, we can see that, again, this indeed is the correct form of our equation that will allow us to find the maximum possible weekly revenue of the price that results in the maximum revenue. H being the price, because our variable P represents price, and then at y representing rate, because our function, or r sub p, okay, the revenue given that price.